to the second video, Good Practices for Data Visualization. Now in the previous video we talked about what is data visualization and what makes it important. And at the end of that video we also talked about what makes a good chart and if there are any principles that could be followed for creating a good chart. And we shared a few of those principles with you in the previous video. Please feel free to go back and review them if you feel the need to. Now in this video, we're going to talk about a few specific types of charts and how to use them. We're going to talk specifically about line charts, pie charts, and bar charts. Let's get started. Now, what is a pie chart? You must have seen this very commonly. A pie chart simply divides a circle into segments. As you can see, all of these circles here are divided into segments. You may have also seen what is called a donut chart, which is simply just a pie chart, but just the center piece is removed. It's just a different way of presenting a pie chart. There is no difference otherwise between a pie chart and a donut chart. Now, here are a few really important things that you must keep in mind when working with a pie chart. Whether you are creating a pie chart or you are trying to analyze information that has been presented in a pie chart. Most importantly, all segments of a pie chart must add up to 100%. Now if you see, this is point number 1. We look at this example 1 here. This is a chart that shows what apps do users use each week, and there's images, video, text and sound, and you see 84% images, 73% video, 65% text and 55% sound. They don't add up to 100%. So then how can they be put in a pie chart like this? You can't compare. Now how is this segment, if this segment is 84%, then how is this segment 73%? They look the same size only. And how is this one 55%? So it's just not possible to have more than 100% displayed inside a pie chart. If that is happening, you either need to use a different type of chart, maybe a bar chart, or you need to recheck your data. Now, second, comparing segments in a pie chart can only give an approximate idea. If you look at this example here, you see this blue pie chart shows 2018 data and this yellow one shows 2019 data. And you have this data displayed here as well. It shows that this blue, the darkest blue is 11.7% and then the lighter one is 13 and like that. Similarly here you have the darkest yellow is 10% and similarly like that. Now all of this does add up to 100%, so in that way this data is okay. But if you see, you can't compare this segment against this segment. They both look very similar, but actually you can tell that they are similar but they're not the same, because if you see here, this segment is 29% whereas this segment is 31.5%. Now if this same information had been presented in a bar chart like this, it is very easy to see that there is a difference here. Between 2018 and 19 it has increased, but here comparing two pie charts, it's very difficult to make that exact judgment. As it says here, comparing segments gives only an approximate idea. So you have to keep that in mind. That does not mean that pie charts are not useful. That just means that you have to acknowledge when presenting data in a pie chart that just giving approximate idea is good enough in this case. Okay, point number 3. Using more than 3 or 4 segments can make the pie chart difficult to read. You see here, if you have about, this one has 4 segments, you can still kind of compare, okay, this red one is the smallest and this one is the largest and this one is still larger than this. They are roughly similar, but this one is larger. That's okay. But suddenly when you have so many segments, how do you compare? Now they all look the same size here, right? So it is a best practice to have only 3 or 4 segments maximum inside a pie chart. And lastly, using 3D pie chart can change the perception of the size of the segment. Now it's important to recognize that in a pie chart, you are drawing information based on the size of the segment. Now in this chart number 4 here, you see here this blue one and the purple one, very clearly the purple one is much smaller than the blue one. But when you look at it here, when you use the 3D presentation, it's not that easy to compare the sizes between this purple, green and the blue one. You see here, the green and purple, the purple is significantly bigger, but here it's not that significantly bigger. And as you know, we are only taking an approximate idea. If you present the chart this way, then someone might think, okay, purple and green are roughly similar only. But if you present the chart this way, you see, oh no, actually purple is a lot bigger than the green one. So it is important to know that presenting any chart in a 3D fashion can change the meaning of the chart altogether. So it is best to avoid presenting charts in a 3D manner. Now here's an example of a good pie chart. Now why is it a good chart? You see, it clearly shows here. It has a simple title. The title gives you a key takeaway. The title says more than half of internet users use Google Chrome. Then it provides readable colors and fonts. You see, the colors are easy to compare. If you look at this pie chart, it's very difficult to compare different shades of blue. They look so similar. But here you can very easily compare the different colors. And the fonts are also easy to read. Then you have clear labels with data values. It shows, okay, this is Chrome 64%, this is Safari 18%. It's very clear to read this data, read this pie chart. And this pie chart makes only one point. It's not trying to communicate multiple pieces of information in a single chart. It's just making one point, and that one point is how many percentage of users use which browser. That's it. It's not trying to tell you anything more than that. All the segments also add up to 100%, which is the critical point about presenting a pie chart. And as you can see, it only has 4 segments, which also checks our good practice list. So this is an example of a good pie chart. Moving on. Let's look at line charts now. Now what is line chart for first to get started with? A line chart simply shows data against a continuous axis, which is usually time. As you see here, it's a continuous axis here. This is the year 1939, 1940, 41, 42 and goes all the way. So the difference between every two data points is that of 1 year. So it's a continuous timeline. Okay. So thus the number one good practice for making a line chart is that the x-axis should be continuous. Okay. And another thing that you can do with line charts is that you can use it to compare multiple lines. As it has been done here, you have the blue and the orange and the red line. You can compare them on a single chart because they're all plotted against the same x-axis. But if you have too many lines, it can be very difficult to compare. As you see here in chart number 3, there are 6 lines drawn on the same chart. And even though there's another mistake that's happening here, you see this is not a continuous x-axis. You see this primary, upper primary, elementary, secondary, higher secondary, this is not a continuous axis, but it still works out in this case. But ideally, this should not have been a line chart, this should have been a scatter plot. So scatter plot means you only have the dots here, you don't have the line connecting them. Because the line connecting them means that there is some point in the middle of 2 points also, but that is not the case here. So here the x-axis is incorrect. But to talk about multiple lines, you see when you have too many lines on a chart and the gap between 2 lines is not that significant, it becomes very difficult to read the chart. And lastly, changing the y-axis can change the meaning of the chart altogether. You see here, when you look at, this is a currency exchange chart. It shows the currency exchange rate from this ZZD currency to QQY. And as you can see, it looks from March 2019 till September 2020. There is a significant increase and decrease. That's what it looks like, because the y-axis has been chosen as 0.75 to 0.78, right? Or you could say 0.74 to 0.79. And you can see between that narrow range, the value has changed quite significantly. It has gone up and down. But if you zoom out and you set the y-axis as 0 to 1, it looks like a very stable thing. Now, in some cases, this might be the correct interpretation, but in other cases, this might be the correct interpretation. So, it is important to recognize that changing the y axis in a line chart can completely change the interpretation of the line chart. Similar to how we saw with pie charts, if you make a 3D pie chart, it can change the interpretation of the pie chart altogether. So, to sum up, instead of a line chart, a scatter plot, as I mentioned here, or a bar chart even can also be used sometimes. Now let's look at an example of a good line chart. You see, this line chart has a simple title, Increasing Gap Between Productivity and Compensation. It uses readable colors and fonts. It only has two lines. They are easy to compare. You have a red line and a blue line. It is easily mentioned here that the blue is net productivity and the red is hourly compensation. And it has clear labels and data values also. As you can see here, it also provides additional information within the chart in these text boxes here. And it uses a continuous x-axis. The gap between every 2 points is that of 5 years here. So this is what a good line chart looks like. It checks all the boxes. Moving on to bar charts. Now, what is a bar chart? Similar to a line chart, a bar chart compares discrete values across categories. Now, difference between a line chart and a bar chart is, if we go back to the line chart, it shows data against a continuous axis. But in a bar chart, it shows a discrete value. Discrete means not continuous. So it means separate, or different values across different categories. Now, the x-axis usually shows the categories and the y-axis shows the values. As you can see here in this chart, the x-axis shows your different categories, dragons, monkeys, cobras, bulls, and the y-axis shows the value, which is this rating from 0 to 2000. But it can also be vice versa. You can have your x-axis as the rating and the y-axis as the categories. Then it becomes a different kind of a bar chart. Sometimes this chart, horizontal one, is called a bar chart and this vertical one is called a column chart. But they're both the same. There's not any difference between a bar chart and a column chart other than the orientation of the chart. Now, you can use a bar chart to compare multiple categories. As you see here, in this one chart, they have shown the flavor preferences by gender. So not only are they comparing gender, so male and female, they're also comparing different flavors, vanilla, strawberry, and chocolate. So you actually have 6 different types of data. So females who prefer chocolate, males who prefer chocolate, and similarly for these other 4 categories. You can show all of this in a single chart. So this is where data visualization becomes helpful. Instead of having to present 6 different rows or say a 3x2 matrix, a table to show this information, a bar chart, like this, a categorized bar chart can easily, help you compare any data point against any other 5 data points. You can simply see that which is the largest count and how does this count compare against all the other ones. You can very easily do that. So that's where a bar chart excels. Then number 3, a good practice for bar charts is that the values should be clearly mentioned. If you see in this chart, there are no lines, no axis lines that help you compare. So if you're looking at this figure, you just have to assume that it is somewhere between 10 and 15, so maybe it is 11 or 12, but you can't, reliably predict what this value actually is. So it is a good practice to always mention the value of the bar on the bar itself. So it can either be presented inside or outside or below, wherever there is space. The value of the bar should be presented to make it easier to compare. And again, as working with line charts, changing the y-axis can change the interpretation entirely. So if you see in this first one, our product versus their product, the quality score for their product is about 85 and for our product is about, I don't know, for their product is like about 92, I think, and for our product is about 95. So you can see that there's not much difference. But if you change the y-axis and you start the count at 90, then it looks like our product is so much better than their product. It's like nearly 3 times better. But that's not the case, right? So changing the y-axis can change the meaning of the chart in a bar chart as well, just like it does in a line chart. And one tip that I would like to give you here is that if there are very few bars, like say there's only 3 or 4 bars, like say like this one, and all the numbers add up to 100%, then you can actually use a pie chart to communicate this information. If that is something that if a pie chart can communicate the information more effectively in this case, then you should definitely use a pie chart instead of a bar chart. And another type of bar chart is called the stacked bar chart, in which the values are stacked on top of each other. For that as well, the two values have to add up to 100%. So these are different alternatives available for a bar chart, but those alternatives are useful only in specific instances. You shouldn't always use them just because they look different or they look new. Now let's look at the example of a good bar chart. Now this one again has a simple title. It compares Maharashtra's growth indicators among children to the national average. It uses readable colors. You have a simple red and blue color scheme. It uses the appropriate scale, so goes from 0 to about 40-50%. It does not look cluttered. The information is very nicely separated, and it provides labels and data values. You can very nicely compare that these two bars, there's a 1% difference between them because it is nicely mentioned here. Similarly, over here also there's a 1% difference because it is mentioned here. So this is what a good bar chart looks like. Let's move on. Now, we've already talked about pie charts, line charts, and bar charts, and we shared a few good practices for each of them. Why don't you pause the video here and test your understanding? Do you think these 3 charts that are presented here, this bar chart, this pie chart, and this stacked bar chart, do they qualify as good charts? Are there any elements that are missing in these? Which elements, which good practice elements are present in these? Here's another 3 charts. Now you have some line charts and a 3D pie chart and another bar chart. Do you think these qualify as good charts? Again, just pause the video and quickly go through all the elements that we talked about. Think about how these charts can be improved. Okay, now just to sum up everything we talked about data visualizations, here are some mistakes to avoid when creating a data visualization. Number one mistake, making a cluttered or like a hodgepodge looking visualization. Avoid that. Number two, trying to say too many things in one chart. Just try to make one point in every chart. Number three, not providing labels and data values or using fonts or colors that are difficult to read, and using incorrect scales and units. As we saw, the y-axis, the scale should be appropriate, it should be correct, otherwise the meaning can change. And second last, adding unnecessary design like a 3D chart. A 3D chart looks different, but that's not why you should use it, because using a 3D chart, if it changes the interpretation of your data, then that is not helpful, even though it looks different. And lastly, not double checking if the data is correct. Right? Sometimes you put something in a data visualization and it looks too good to be true. Like, oh, look, the data is saying something so different from what you normally believe. It is possible that the data is probably incorrect. So you should always double check your data before you present it in a data visualization. So if you were to sum all of this together, it would simply be keep it simple. For a data visualization, just keep it simple. Here's a few resources that might be helpful. As I mentioned in the FAQ webinar that we conducted a few weeks ago, always take a look at the Microsoft support website. They have a lot of great information and tutorials, video tutorials available for all things to do with Microsoft Office. And if you just search on YouTube for data visualization, you'll find a lot of information as well. Thank you. I hope this was helpful. I'll see you in the next module.